Okay, we're in section 133. As always, you'll have contents, examples, and then exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. The PDF that you're looking at here is being made available to the Prism Mathematics participants only. I realize other people may be watching these videos and are interested in getting a copy of this document. It's not published yet, but you can reach out to me and I'll inform you when it's going to get published and where to get it. Let's see, my email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right, let's look at the contents. Again, I'm not going to read it to you. The expectation is to read through that and try to make some sense out of it. So we'll talk about binomial equations, and then, certainly what I want to encourage you over here is that we've certainly done binomial equations before. They're the form, this over here. So it's going to be x to the nth power equals a. So this should be x to the n minus a equals 0. All right? So the bottom line here is we've done these before, and we've done them in a variety of ways. Certainly if you got x squared equals, let's say, 7, then x would equal, we've done it this way, plus or minus the root of 7. What else have we done? Maybe something like this over here, x cubed equals 8, and then what you did was here you probably try to use zero product rule, or you just simply said, oh, x is 2. But let me put this down for you. X cubed minus 8 equals 0. Then you might have tried to factor it. Let me put down what I mean by that. X minus 2. It's the difference of perfect cubes. Looks fairly simple. And what would you get over there? And there's many ways to do it. You could also do it by long division. But let's take a look at it. You get x squared. And we've actually done this one before. Then you're going to get plus 2x plus 4. All right? So I certainly know one root, x equals 2, or the other one would be when x squared plus 2x plus 4 equals 0. I'll use the quadratic formula to do that. You know what? Let's use completing the square. And what do you get over there? X squared plus 2x equals minus 4. Complete the square by taking half of 2, which is 1. Square it, you get plus 1. And what do you get? A perfect square. X plus 1 squared equals minus 3. Whoops. And then x plus 1 would equal plus or minus the root of minus 3. X would equal minus 1 plus or minus, well, the square root of minus 3 is I root 3. So we found 3 roots, all right? Now, certainly stuff we've done before, and certainly you could do it, for 4th degree, 5th degree. Well, the 5th degree is that when you start getting trouble. But again, if you have 4th degree polynomial, like let's say I said x4 is equal to 16, then you do x4 minus 16 equals 0. Then you do x squared. Let's write this down. It's pretty easy to do. X squared. I'm just factoring what we've done in the past. And we're using simple examples here. All right, then what do you do? X squared would equal 4, or x squared would equal minus 4. What does x equal? Plus or minus 2. What is x over here? Well, let's see, plus or minus 2i. All right? So I'm going to say we've certainly done problems like this before. And my claim over here is that we want to kind of move forward with that same thing in mind. But once you get to a 5th degree polynomial, things are going to get a little bit more difficult. All right? And there's many ways to do it. I'm not saying there's only one way to do it, and there's many ways to do it. This is a binomial. What I mean by that, if you put this down, you get x5 minus 32. That's a binomial, is equal to 0. Well, the first thing I would do is realize that, factoring does work, right, partially anyway. What do you get over here? You would get x minus 2 times something. Now, someone says, how do you get that other part? Well, we've been doing this for some time, and I'll write it down for you. We would divide x minus 2 into, I'll write this down for you, x5 minus 32. And we've been doing this for a long time. Let's see what you get. You get x4. That would give you x5 minus, let's see, 2x4, right? Subtract, you get 2x4 minus 32. You keep repeating. Again, just doing some side work over here. That's going to be plus 2x cubed. What do you get? 2x4 minus 4x cubed. Subtract 4x cubed minus 32. Let's keep going. What do you do now? Let's take a look. It's going to be plus 4 now, right? 4x squared. What do you go there? 4x cubed minus 8x squared. Well, I got to subtract now. You get 8x squared minus 32. And then what do you get? Well, let's take a look. It looks like plus 8, right? Plus 8x. What do you get? Did I make a mistake somewhere? Oh, no, 8x. I'm sorry. That's going to be 8x squared minus 16x. Boy, it's a lot of division, isn't it? 16x minus 32. I'm actually running out of room over here. And it looks like plus 16 now. So I'm going to jam that in over here. And what do you get? 16x minus 32. As expected, remainder 0. So I'm going to write that down for you. That's going to be x4 minus, not minus, plus 2x cubed. And then plus 4x squared. And then plus 8x plus 16. Let me get my eraser out, because that long division is something we've been doing for a very long time. And again, the reason I go through it is to make sure that you can do that as well, that you want to be able to do that long division. It's kind of chicken scratch on the side somewhere. But I got it factored, partially factored anyway. There's a problem now, and I'll tell you what the problem is. It's this guy over here. However, it is simpler than a 5th degree polynomial. Now it's a 4th degree polynomial. It's depressed, all right? So our recommendation here is to, for these binomials, is to do something, all right? So what I'm going to recommend is you divide both sides by x squared, all right? Now what I mean by that, I'm not, let me point out what we're talking about over here. We're not talking about this one. We know the root of that. It's this guy we're talking about, all right? So what I want to do, I'm going to divide by x squared. And let's put that down. And the reason I'll get a quadratic, or something that looks like a quadratic from that when I do that. So if you divide by x squared, what would you get? You would get x, let's see, you'd get x squared, let's see, plus 2x, plus 4, plus, well, it's going to be more difficult, right? That's going to be 8 over x, plus 16 over x squared. Now, I realize some students are looking at that. That's crazy looking. What are you going to do with that? Well, I'm going to try to pull things together to make it look more like a quadratic to me. All right? So let me, again, we're trying to figure something out in this one. So let's write this down. So I'm going to say x squared plus 16 over x squared. I did this one and this one. And then the next one I put down, let's combine two things together. Maybe I combine these two together now. I'm looking at the terms with x squared in it, terms with x in it, and I immediately notice that 2 comes out from that. All right, again, I took the first, I took this one and this one, they had squares in it. I'm going to do the linear terms, and that 2 comes out, right? So we're left off with x plus 4 over x. And then what do you get in the end? You get plus 4. All right? Now, looking at it, it sort of looks quadratic. And I'll write this down. I'm looking, when does this equal 0? Let me point out over here. I was trying to do this over here. Let me make sure you understand what I'm doing. We took x4 plus 2x cubed plus 4x squared plus 8x plus 16. We're trying to figure out when it's 0. I know x isn't 0, by the way, so I divide by x squared. And that's where I am now. I'm right here. I'm looking at that. And I'm wondering, make a substitution here. Let's see if that happens. And I'll get my little eraser out. It's just me explaining why I did all that business here. So I make a substitution now. So the substitution I'm going to let u equal x plus 4 over x. All right, now, again, I'm hoping to get a quadratic out of this in u. So let me write down u squared. And u squared would equal what? X squared plus 16 over x squared. I want to point out, if you're getting lost over here, you may want to write this down. What I'm doing is x plus 4 over x squared. And really what we're doing is x plus 4 over x times x plus 4 over x. All right? That definitely gives me x squared plus 16 over x squared. And then you get the middle term. What do the middle terms be? Let's take a look at it. you would get, let's see, 4 plus 4 is 8, right? So I'll put that down for you. All right? Now, I got to write that down because I'm seeing something like that, but I don't really see it totally. So let me write this over here. So it's going to be 0. I'm going to write this now as x squared plus 16x squared. Now I'm going to put a plus 8 over here. Now I want to make sure you understand if I add 8, I got to take 8. But let me just keep writing this down. I want to make sure that these are the same problems. Plus 4. Remember, I got to take 8. Now that's a lot of work. There's no doubt about it. All right, is that the same as what we have up here? Well, I hope you agree it's the same. And what am I seeing now? Write this down. It's going to be 0 equals, what would that be? That would be u squared, right? That's right here. Plus 2u. That's right here. And 4 minus 8 is going to be what? That's going to be minus 4. All right, we're going to solve for u now. It's a lot of work, I know that. By the way, there's easier ways of doing this, but we're just trying to go through what we have to do here. Well, that's going to be not too bad, right? So I'm going to add 4 to both sides. And again, we're solving for u. That would be u squared plus 2u. And then we complete the square. We take half of 2, which is 1, and add it to both sides. This would give me 5. And then I get u plus 1 squared. So u plus 1 would equal plus or minus the root of 5, or u, and it's going to get more difficult, by the way, minus 1 plus or minus root 5. Now someone says, why does it get more difficult? We got to do this now. We got to figure out what x is. And this is why it gets so difficult, all right? So I'm going to write that down for you. It's a lot of work. I'm not saying it's not. But I'm going to outline another procedure. When you take trigonometry, solving this is much, much easier when you take trigonometry. All right, but right now we're not there yet. So what do I got here? I got x plus, that's what the u is equal to minus 1 plus or minus the root of 5. And yes, I know it's frustrating. I got to solve 2 equations now. And I'm going to do one at a time for you. Whoops. Again, don't be discouraged by work. I'm going to say minus 1 plus root 5. And the other one I want to do is x plus 4 over x equals minus 1 minus root 5. Yeah, they're kind of nightmarish, but I know how to solve these equations. And you're going to get x squared, multiplying both sides by x, plus 4 equals, well, let me write this a little different. It's root 5 minus 1 times x. I'm going to write this in a standard form, which is going to be x squared, let's see, plus 1 minus root 5, x plus 4 equals 0. Let's go over here and do the same thing. We're going to get x squared plus 4. And I'm going to write this as, let's see, minus 1 minus root 5 times x. I'm going to put it in standard form. What are you going to get here? X squared plus 1 plus root 5, x plus 4 equals 0. Yeah, I know it's annoying, but we got to solve that. All right, we have to solve it. And how would you do that? It's not easy. All right, but I got to write this down for you. I'm going to use quadratic formula, and I'm going to do the quadratic formula on this guy first. All right, I'm going to put this over here. And what do you get? X equals, let's see, the opposite of b, which would be root 5 minus 1 plus or minus. The root's going to be a real nightmare. The bottom I'm going to put down pretty quickly, just 2. Now I got to do the b squared. All right, that's going to be 1 minus root 5 squared. Let me write that down for you. That's going to be 1 minus 2 root 5s plus 5, which can be 6 minus 2 root 5s. Let me cross this out. That's the b squared, by the way. Now I got to do the 4 ACs, right? So 4, the a is 1, and what's the c? The c is 4. What's that going to be? Well, let's write this down. And again, I'm just doing my side work over here. 6 minus 2 root 5. That's the b squared minus 16. And what do you get there? Minus 10 minus 2 root 5s. I'm going to write that down for you. All right, that's not so bad. I got troubles, though. Let's put the troubles down for us. X equals root 5 minus 1 plus or minus. I got to figure this part out now. Let's write this down for you. That's going to be what? Well, I'm going to factor out a minus 2. And you're left off with what? 5 plus root 5 over 2. What do you get over here? And it's a nightmare. You get root 5 minus 1 plus or minus I. And this would turn out to be 2 times 5 plus root 5. Now that's a nested root. We can remove the nesting. But I do want to point out these answers are listed for you over here. And let's just make sure we got that one down. Root 5 minus 1, I got that. Plus or minus I. Yep, I got that. 2 root 5. Well, they multiplied it out plus 10. That's fine. They multiplied it out. It's a nested root, though. You can remove the nesting. And it may not be a bad idea to remove the nesting on it. And that's something we've done a long, long time ago. All right, now the other one, very similar. I would say do that on your own. What are you doing over here? You're doing this one over here. And use the quadratic formula again. You know, what I mean by that, it's x equals, that would be a minus 1 minus root 5 plus or minus the b squared. Well, the b squared is pretty simple. Let me get my eraser out. I'm going to leave it as an exercise. I'm not going to do the whole thing for you. Let me get my eraser out because I want to get rid of my scratch work over here. And again, scratch work is important when you're doing things. So, you know, the b squared there is going to be what? That would be, let's see, 1 plus 5 plus 2 root 5s, which is 6 plus 2 root 5s. You get the idea. And then, you know, minus 16. You do this. The bottom is 2. And simplify it. And you should get this thing staring at you over here. All right, it's a lot of work. But what I claim over here, when you do that, you're going to get 4 solutions to the problem. Right, 4. All right, now what do I mean by that? If you recall in the beginning, we had a really easy one, and that was x equals, let's write that down for you. That was x equals 2. We did that in the very beginning, and then we got these 2 over here and these 2 over here, for a total of 4. Now, why do I say 2? There's 2. There's 2 of them, all right? They're complex, by the way. Right, that's a lot of work. Now, of course, when you take trigonometry, and I want to point out to you, we're not there yet. Wells does mention it, but this French mathematician, de Wav, comes up with this really nifty way. And again, when you study trigonometry, you're going to see that these things are super simple to write down. And someone says, you know, why are they so simple to write down? Well, you have to wait to study trigonometry to see that. But you can write these answers down, I mean, incredibly quickly. Right, incredibly quickly, looking at the problem. And that's an important thing. It has to do with complex numbers, by the way. But the bottom line is, you know, remarkably, these things are going to be really simple to compute later on. But right now, don't worry about that. Other than the fact that Wells does mention it, and by mentioning it, it's important that when someone mentions something, that he's kind of, you know, giving you a heads up what your future holds. It holds these things. It holds a lot of simple ways of doing things. But here's the deal. When you're going to do the exercises, right, they're going to be these quadratics. I'm sorry, these binomials, right? Same technique, by the way. What do you mean by that? There's a real simple solution to this. What's the solution to this one? 1. You're going to divide by 1. You get this thing over here. Then what do? Divide both sides by x squared. You're going to get something pretty simple out of that. You know, you know, substitution. Look for something. It becomes quadratic. And then you're going to get 4 solutions to that as well, all right? What are the 4 solutions going to be? Well, 1 is really easy. That's a solution to that. And then there's 2 more. And those 2 more really reflects what we've done in the past. It reflects it, all right? So, again, it says you'll learn a simpler way when you take trigonometry. And that's true. You'll learn a simple way to do it. But right now it's complicated, right? Over here, a little more complicated. What's the root over there? Minus 1. What are you dividing by x plus 1? You get this over here. But the same thing. Same exact thing. Divide by x squared, you get this over here. You need practice, though. You need practice doing that. All right, this one over here, a little more abstract, right? But again, the root of that would be where x is equal to 5. You do that right over here. Again, same thing, divided by x squared. I put all the work down there for you, and I go through it. There'll be 5 solutions as well. And again, they're not easy, but you can do it, all right? And that's about it, all right? So next up, SAGE, let's just talk about it briefly. What's SAGE? Computer Algebra System. We've been talking about this for some time. CAS for short. It's open source software. Go to this website over here. You can either download it or use the interactive web-based application available at that website. Type this stuff in over here. Basically just me typing things in. You may want to look at that, try to make sense out of it. But here's the intent. The intent is not to do SAGE. The intent is to do Wells's work, all right? Again, I want to point out, I probably made some errors. I hope they're not substantial errors, but you may say, hey, you typed something wrong or you got a wrong answer. I love hearing from students. And again, what are you looking at? You're looking at my work, all right? You're going to learn by that. That's how I learned math. I looked at other people's work. I studied their work, and that's good. Hopefully the work is good, though. I also learned by looking at work. And by the way, what I mean by that, some work you look at is horrifically bad. For example, students' work sometimes, especially if they don't study, their work is horrific. You don't really learn from horrific work, though. But you do learn by looking at work from students who work hard because they see different things than you see. And that's important. When you're looking at good work, you're going to learn from it. And I have learned from good students, right? I've seen them do things. I say, I wonder why they're doing those things. And then I have to study what they've done to see what they've done, all right? And that's important. You're going to learn by looking at other people's work. Are you going to develop your own skill set? Yeah, you're going to develop a skill set by working. But here's the deal. If you're seeing any errors in my work, I don't care how small they are, please reach out to me. But please, when you reach out to me, tell me where you are, right? Otherwise, I'll have no idea what you're talking about. For example, if you're doing these exercises here, tell me you're in section 133.3 exercise and you're doing problem number 1 and you believe there's an error and this is why you believe there's an error. You tell me. I will look at what you write. I will look at what I wrote. I will try to get a reconciliation between the two. And if you're correct, you will get credit. In other words, your name will be listed in this text. All right, it will be listed and I'll update it and the community will benefit by doing that. Thank you.